You know, it's funny, to build the homes of the future, we actually have to look to the past. Not to copy old styles, but to reclaim this ancient wisdom of designing buildings that work with nature instead of fighting against it. This is really the heart of bioclimatic architecture, and it's our blueprint for building truly carbon-neutral homes.
All right, so here's the game plan. We're going to dive right into this architect's playbook. We'll kick things off with the why, the energy imperative. Then we'll get into how to read the land, use geometry to our advantage, harness the sun's power, design the building's skin, and finally, see how the whole thing comes together as one living, breathing system.
So, first things first, why are we circling back to these basic principles now? Well, you gotta understand the problem we're even trying to solve here, the absolutely massive and pretty recent energy footprint of our buildings.
Wow, this chart, it really tells the whole story, doesn't it? We went from these smart, low-energy vernacular homes that were designed for their specific climate to these energy-guzzling, international-style boxes that basically ignored the environment and just relied on brute force mechanical systems. The goal now? A pretty radical return all the way back to zero. And this single idea is the key to absolutely everything that follows. It is a total paradigm shift. A house isn't some machine that just consumes power. It's a carefully designed filter that selectively invites in the sun's warmth and the wind's cooling breeze.
Okay, so this leads us to what is maybe the most important point of all. Before you even think about sketching a floor plan, you have to understand the land itself. This is the real starting point. Let's really look at this diagram, right? You see a few different places you could put a house on this hill. The arrows show you the winter winds. Now, look at the ideal spot, marked A. It's tucked into the slope, so it's shielded from those harsh winds by the top of the hill, but it's still wide open to the sun. This one decision isn't just about getting a nice view. It's literally the difference between fighting nature for the next 50 years and getting a free assist from it.
And the stakes here are incredibly high. For example, if you build up on that exposed summit, you can increase the wind intensity by a mind-blowing 125%. Think about what that does to your heating bill.
So really, it all just boils down to this one simple, powerful mantra. In the winter, you turn your face to the sun to soak up all that free heat. And in the summer, you position yourself to catch the wind for free air conditioning. This simple idea guides everything else.
All right, we've got our spot on the land. Now what? Well, now we talk about shape. Once you have your site picked out, the building's very geometry becomes its first line of defense against the elements.
Okay, so this brings up a really key concept called the form factor. And don't let the name scare you, it's actually super simple. It's just the ratio of a building's skin, its outside surface area, to the space inside it. The goal is a low form factor, because the less skin a building has, the less heat it can lose.
And really, this is just common sense when you stop and think about it. A compact, simple shape like a cube holds the most volume with the least amount of surface area. But a complex, sprawling shape, it's got way more skin exposed to the wind and cold, just constantly bleeding heat.
And you know where we see this perfectly? In nature. Penguins huddle together in these tight groups to survive the Antarctic cold. They're reducing their collective exposed surface area to stay warm. A compact building is doing the exact same thing. It's a survival strategy, just written in geometry.
But here's the thing. Compactness isn't always the answer. It's not a one-size-fits-all solution. This chart, which is based on the amazing work of architect Victor Olgier, shows that the perfect shape really depends on your climate. In cold regions, yeah, a super compact cube is what you want. But as you get into hot, humid places, the ideal shape actually gets longer and thinner, so it can catch those all-important cross breezes.
So, we've got a site and we've got a shape. Now we ask what might be the single most important, and, believe it or not, cheapest question in all of green building. Which way do we point the front door? The impact is just enormous. Just by pointing a building in the right direction, getting its main windows to face the sun correctly, you can slash total energy consumption by 20 to 30%. That is huge, and it costs you basically nothing. It's a free win.
This table breaks it all down, and you can see why orientation is such a big deal. In the Northern Hemisphere, facing south is the undisputed champion. Why? Well, in the winter, the sun is low in the sky, so it shines right into your south-facing windows, giving you free heat. But in the summer, the sun is high overhead, so it's incredibly easy to block with just a simple roof overhang. East and west-facing walls, on the other hand, they get blasted by that low-angle morning and afternoon sun, making them an absolute recipe for overheating.
Okay, now we're going to zoom right in on the building's skin, the walls, the roof, the floors. And we're going to stop thinking of them as just, static barriers. We're going to start seeing them as a dynamic, rechargeable battery for heat.
And that brings us to this incredible idea, thermal mass. Basically, heavy, dense materials like concrete, stone, or brick have this amazing ability to soak up heat and hold onto it for a long, long time. They literally act like a thermal battery, charging up when it's warm and then slowly releasing that heat back into the house when things get cool.
So how do you charge this battery? Well, there are a couple of ways. The simplest is what's called direct gain. Sunlight just streams through a south-facing window and heats up a thick concrete floor. Or you can get a bit more clever with indirect gain, like with a trombe wall. That's basically a dark, heat-absorbing wall on the outside of the house, covered with a pane of glass. It soaks up the sun's heat all day and then radiates it slowly into the living space hours later, long after the sun has gone down.
And this is where you see the magic happen. Look at this graph. That crazy wavy line, that's the temperature outside, swinging wildly from day to night. But that beautiful, flat, solid line, that's what's happening inside the house with all that thermal mass. It's acting like a giant shock absorber for temperature, smoothing out those peaks and valleys to keep things remarkably stable and comfortable.
All right, for our last section, let's pull the camera back and see how all these pieces fit together. Because a truly bioclimatic home isn't just a box of smart tricks. It's a single, cohesive system that lives and breathes with its environment.
You see, at the end of the day, this isn't just architecture we're talking about. It's a synthesis. It has to start with biology, understanding what actually makes human beings comfortable. It's guided by climatology, knowing the specific patterns of sun and wind for that exact spot on Earth. It's enhanced, of course, by modern technology. And then architecture is the art that weaves all those threads together.
And that really leaves us with one final and kind of provocative thought to chew on. In our excitement for all the high-tech gadgets and shiny solar panels, have we maybe overlooked the most powerful green technology of all? Perhaps the timeless, passive intelligence of shape, location, and form itself is the ultimate tool we have to build a sustainable future.